Today, let's learn about related rates. If you remember four things, you can easily solve related rates problems. First, condition. Find out what condition is given in the problem. Second, question. Identify what the problem is asking for. Third, relation. Try to relate the variables given in the condition and question. Lastly, differentiate the relation with respect to time. Now let's apply this to solve a common related rates problem. The ladder problem. To solve the ladder problem, we first need a ladder. So let me quickly draw it. Now that we have a model, let's use a 3D printer to print out the ladder we designed. There we go. It looks like it printed out well. Now let me show you how the ladder will slide.
Ugh!
As you saw in the previous video, a 5-meter ladder starts to slide. When the ladder's bottom slides at a rate of 10 meters per second away from the wall, we need to find the rate at which the top of the ladder is sliding. Alright, let's start by drawing the diagram. We have a 5-meter ladder with a distance x from the wall and a height y. Let's look for the first condition among the four things we learned earlier. The problem states that the base of the ladder moves at a speed of 10 meters per second, so this will be our condition. Therefore, we can write this as dx over dt equals 10 meters per second. And since the problem asks for the speed at which the top of the ladder moves, we call this dy over dt. So our question is finding the value of dy over dt when x equals 3. Now we need a relation that can connect the variables x and y based on the given condition and question. In difficult related rates problems, finding this relation can be challenging, but by looking at the diagram on the left, we can easily use the Pythagorean theorem to find x squared plus y squared equals 25 as our relation. Now let's move on to the last step, which is the fourth step. We'll differentiate the relation we found with respect to time. Using implicit differentiation, we'll differentiate both sides with respect to time. Then we get 2x times dx over dt plus y times dy over dt, and the constant term on the right side becomes 0 when you differentiate it. We need to find dy over dt, which is the value we were asked to find in this question. Let's divide both sides by 2 to simplify the equation. We'll move the dx over dt term to the right side, and then divide both sides by y to isolate dy over dt. This gives us negative x over y times dx over dt. Even though the question only asks for the dy over dt when x is 3, we still need to know the value of y. Looking back at the relation we found earlier, we can plug in x equals 3 to get y equals 4. Since y represents a length, we'll discard the negative solution. Finally, we can plug in the values of x and y to find that dy over dt is equals to negative 3/4 times 10 meters per second, which simplifies to negative 30 or 4, and it becomes negative 7.5 meters per second. The negative sign is because y is decreasing over time. So if you can identify the condition, question, relation, and differentiate it with respect to time, related rates problems won't be difficult anymore. I will continue to share my tips and tricks through my channel to you guys. If this video was helpful, please like and subscribe for more content. Thanks for watching, and I've been your math guardian, Alex.